And if this being a steroid, we know it cannot be contained by any membrane, be it the membrane of a cell that synthesizes the hormone, or be it the membrane of the cell where the hormone acts. Whatever it is, the membrane cannot able to contain this molecule testosterone. As a consequence, let me take up few testosterone molecule here, people. So let's take up molecules of testosterone. Now when it comes close to the cell, the binding protein stays away and only the hormone enters into the cell, right? So let's bring these hormones into the cell here, guys. Now since they are all lipids, they don't have any restriction, they can be easily coming into the cell membrane. They'll easily diffuse across the cell. Once they come into the cell, these hormones will be combining with receptors, right? Now this receptor is going to be called as androgen receptor, guys. Androgen receptors are usually located in the cytoplasm. They are located in the cytoplasm. And there are other androgen receptors as well present in the cytoplasm. So now let me give you two kinds of androgen receptors, one in black and the other one is going to be in red color. Androgen receptor indicated by AR, alright. Now inside the nucleus there are going to be chromosomes. So let me take this as chromosome here. Inside the nucleus it's a double helical spiral. So this is one chromosome and there is going to be another double helical spiral here, right? So what's going to happen, every time the hormone comes into the nucleus, every time the hormone comes into the cytoplasm, the hormone is going to come and combine with the receptor. There is going to be hormone receptor binding. And once the hormone receptor binding, what's going to happen is, this complex, hormone receptor complex as such, is going to be translocating from the cytoplasm into the nucleus. They go and combine with the genes straight away and exert their action combining to the genes, and these kinds of actions are called as genomic action. Guys, whatever you just learnt is going to be genomic actions. So this is one way of expressing the action of testosterone, where the hormone and the receptor is going to combine directly over the chromosomes. On the other side, the hormone which is combining with the androgen receptor in the cytoplasm, they themselves exert a separate kind of action which has got nothing to do with genes. They are completely unrelated to genetic modification, but they stimulate some ion channels, they stimulate some other mechanism of action, some enzymes, some secondary proteins. These kinds of actions are called as non-genomic actions, guys. Non-genomic actions. So please understand, when it comes to testosterone, it has got two kinds of actions. One is genomic and the second one is non-genomic, doctors. Alright. And let me give you another example here. Let us consider there is a receptor here, there is another receptor here. There's another receptor here. Alright. So again, these two are androgen receptors. They both are androgen receptors. We'll put it this way. On one side, we get this full hormone testosterone coming in. On other side, the same testosterone hormone is being converted to dihydrotestosterone. We'll put it this way. This gets converted by the same enzyme 5-alpha reductase, and this gets converted to another hormone. Now this is going to be called as dihydrotestosterone. So between testosterone and dihydrotestosterone, which is going to be more potent? We'll put it this way. The one that you guys are seeing in brown is going to be basically testosterone molecules, and the one that you are seeing in red, this is going to be dihydrotestosterone molecules. So between these two molecules, the affinity of dihydrotestosterone, the affinity of dihydrotestosterone to the receptor is going to be much stronger, right? It's going to be very much stronger than the natural affinity for testosterone per se. So here the affinity is quite low and less, whereas when it comes to DHT, the affinity is extremely strong, and that is how much of the time testosterone gets converted into dihydrotestosterone before it exerts its action, people. Right. So that's the mechanism of action. And the receptors. The receptors are going to be called as nuclear receptor type 1. People, this word differs from textbooks to textbooks. Now what you are studying here is a word given in Harrison's textbook of internal medicine, and that's kind of more authenticated than what we study in our basic physiology textbooks. Alright. So to be precise, this is nuclear receptor type 1, But if you want the name given in physiology textbooks, consider this as a cytoplasmic receptors. The other name is going to be cytoplasmic receptors, but what is given in medical textbooks is going to be nuclear receptor type 1. But whatever it is, it can be nuclear or it can be cytoplasmic. The ultimate name is going to be intracellular receptors. So when it comes to your exams, even if your external is not willing to accept this name, a nuclear receptor type 1, it's alright. Just tell him that, sir, it is an intracellular receptor, or ma'am, this is an intracellular receptor. That's more than enough, people. Don't worry about it. Here, at this point of your career, you will not be expected to be extremely precise when it comes to action. If you do so, well and good. If not, relax. It's not going to be of any disadvantage or any bad consequences, right? So your marks will not be deduced. So just stay happy and keep pursuing your learning. So that's testosterone doctors.